Hi everyone, my name is Enrico Bottazzi and I'm a researcher at PSC, which is a team part of the Ethereum Foundation. And today I'm going to speak you about Gridlock, which is a protocol for multilateral obligation netting in MPC. And this is a joint work with my colleagues Nam and Masato. So first of all, let's start with the concept of multilateral obligation netting, which might be new to many of you. In order to understand that, I'm going to introduce you to two preliminary notions. The first notion is the one of what is an obligation. So when a business sells goods or services to another business, they usually don't get paid immediately. Instead, what they do is they issue an invoice to the buyer, and this invoice represents a financial obligation that the buyer needs to pay the seller into some amount of time. And the second concept is the concept of liquidity. So liquidity refers to the availability of cash of a business, and this is important to meet their obligations, so to pay their bills, to pay their customers, or to leverage some new business opportunity, for example. So let's get into the concept of obligation netting. So the one that you see here is a obligation network. An obligation network is made by firms. So in this example, we have 3 firms, and each firm has a balance. You can think of it as their cash availability in the bank. And there are also obligations in this network. So the edges that you see represent the obligation between the firms. And in this example, we are kind of stuck because each firm is waiting for another to make them a payment in order to complete their payment. So if we take, for example, firm 1, they are waiting for firm 3 to pay them 80K in order to complete their payment to firm 2. And the same goes to the other 2 firms. And this is technically called as a gridlock situation, when you are kind of stuck. And the only way, apparently, that you can solve this situation is by injecting money from the outside. So normally, one firm will get a loan from a bank and kind of unlock this gridlock. But that's actually not the only way to unlock the gridlock. You can perform what is called netting. So the netting operation is basically calculating for each firm. You see it on the right. What's their net balance? That is calculated by taking their starting balance, subtracting the debts, adding the credits. And as long as this net balance is greater than 0, you can kind of remove this obligation from the system. And this allows to unlock this gridlock without any injection of external liquidity. That might be expensive or might be cumbersome for the firms involved. And this is a real example of this concept of obligation network in Sardinia. This is provided by Sardex, a business. And you can see that this obligation network is made by thousands of businesses. And you see colored, these are so-called cycles of obligation. And each cycle of obligation is a way that allows to remove this obligation from the system. So without being too theoretical, you can kind of understand it intuitively. Like if I owe money to Alice, Alice owes money to Bob, and Bob owes money to me, we can kind of remove this cycle, and we are all okay, all done. And how this is done in the real world, how would you build this system? You would probably hire an agency, a trusted third party, which will receive the invoices from the firms, reconstruct the graph, perform the netting, and return the updated invoices after the netting to the firms. And this is not only a theoretical concept. This is actually something that already exists in the real world. And this is done, for example, in Slovenia, in Europe. They are implementing this multilateral netting on a countrywide level since 1991. And to give you some data, in 2019, this procedure helped clearing over 200 million euro And this came with a participation rate of 1.2% of the total of the firms in Slovenia. And what are the benefits of this procedure? Well, the first one is kind of immediate to understand, is a direct benefit that comes from the liquidity saving for each firm. But there's also an indirect benefit that is more applicable to the wider network and a wider economy of a country. And as you can imagine, greater participation leads to greater benefits. So the more firms you have, the more likely you are to detect cycle and therefore to remove liquidity from the system. And this leads us to the research hypothesis of Gridlock. And our research hypothesis is that the use case, the application in Slovenia, gather a low participation rate. We set it 1.2% in 2019, because the firms were required to give up all their data to this agency. So they were required basically to give up their all financial statements, their all business relationship to this government agency. And what we believe is that if we allow this netting to be performed in a privacy-preserving way, there will be higher participation, and this will lead also to greater benefits to the participants and also to the economy as a whole. So now we go more into Gridlock, and I'm going to touch, let's say, a few technical aspects of Gridlock. The kind of setup is the same that I described before, except for a kind of crucial thing. So on the top right, we no longer have an agency, but we have a set of MPC nodes. And their role is basically the same one as the agency, but there's a difference, of course, because they are performing this operation as a secure multi-party computation. So we have this set of computing parties, and each firm will secret share their data, their invoices with this set of computing parties. And from the point of view of the computing parties, one node only really has a share of an invoice, and this share is meaningless, doesn't carry any meaningful information about the underlying data. In this setup, the nodes can perform any arbitrary function f over the inputs, and in this case, the arbitrary function will be this netting function. And the data privacy right now in this setup is guaranteed under some predefined threshold security assumption. So if we have 4 computing parties, we can create a n out of n threshold. That means that only if these 4 parties collude and kind of collaborate, they can then reconstruct what are like the inputs or the outputs of this function. But as long as one of these computing party is honest, they will never be able to reconstruct the data of the firms. And I kind of alluded many times to this concept, this abstract concept of privacy, but what does privacy mean in Gridlock? We have 2 notions of privacy. The one on the left, which is the weaker notion of privacy, is amount privacy. So this means that from the point of view of the computing parties, all the data related to the obligation amount, all the data related to the balance of the firm is hidden. They cannot see that. While a greater notion of privacy is network-shaped privacy, which means that even the existence of an edge between 2 firms is oblivious from the point of view of the computing parties. So in this scenario, the computing nodes cannot even learn that there's an existing business relation between 2 firms. And you can understand why this is a stronger notion of privacy. And also it comes with like a, let's say, more performance challenges. And just getting a bit into the technical part, this is actually how we define the algorithm of netting. And this is, in computer science, is defined as an optimization. optimization algorithm. And in our setup, we have an obligation network that involves n firms. We have a matrix A of shape n times n, which contains this obligation, and a vector B, which is the net balance vector. And the goal, the optimization problem, is to find a matrix O prime such that the grand sum function is minimized. So it means that we need to minimize the grand sum of the updated obligation subject to these two constraints. The first constraint is telling us that the balance should be maintained between the initial state and the updated state. And the second constraint, which I think is really important, is that the updated obligation should be less or equal than the initial obligation. So we're not, during the netting, we are not creating any new obligation. We are at least reducing some existing obligation. So what are like the targets in terms of performance? So we start from this claim from Fleischmann that is claiming that if at least 40% of the firms in a country will join this procedure, this will lead to a liquidity saving equal or greater than the 10% of the national GDP. So you can think this is like a very huge achievement if possible. And taking the Slovenia use case as an example, this would equal to 100,000 firms. And what we are targeting as a performance is we want to perform the netting for 100,000 firms in less than 8 hours using MPC. And just to make you understand on a very high level, like performance in MPC, it's way slower than what you would do if you were just outsourcing it to a single agency, because it requires a lot of communication between these computing nodes. So that's why let's say, the target is not as fast as you would get into a single player setting. I wanted to mention also that this concept of gridlock doesn't only apply to this countrywide netting procedure. It also applies to interbank netting. And this is something that this netting procedure is already done by banks almost on a daily basis. And of course, the way it is done today is not privacy preserving. So you can apply gridlock to banks too. You can apply to achieve privacy preserving rebalancing on payment channel networks. And lastly, another interesting application that I came across is this trade chain detection in a bartering network. So to recap what we discussed today, like some takeaways from my presentation. So we got an intuitive understanding of multilateral obligation netting. And I think the most intuitive way is just to think about I owe money to Alice, Alice owes money to Bob, Bob owes money to me. So we kind of can simplify this network. The second thing is that, at least when applied to firms, to businesses, this generates liquidity savings from the participant, which is very important, especially for small and medium enterprises. And the more are the firms joining this procedure, the higher the benefits for all the participants. And as of today, we saw the example of Slovenia, and this procedure is done using this trusted third party. And by design, this solution requires to give up the access to your data to this agency. While what we are doing at Gridlock is to replacing this agency with a set of parties that perform this netting operation in MPC. And by doing that in MPC, we achieve stronger security assumptions for the privacy guarantee on the data of the parties. So just to conclude, this is a research project. So it's not a business, it's not a startup. You're going to see a paper being published around September, I guess. And if you scan this QR code, you will find any reference to me, my co-authors, a short write-up on the project, and also any reference any paper that has been referenced during the presentation. Thank you.